Hey guys, welcome back to another video. This is still in our statistics unit, so this will be 8.4. So go ahead and write 8.4 here at the top. And what are we learning? We are going to learn about using random samples to compare populations. So in this one, our learning intention is to use random samples to compare populations. You will know that you are successful with this when you can compare random samples using measures of center and variation, when you can recognize whether random samples are likely to be representative of a population, and when you can compare populations using multiple random samples. All right, so here is just a little blurb to give you some information. You do not need to have all of the data from two populations to make comparisons, okay? That would be really time consuming and be really hard when your populations are huge, okay? So you do not have to have all the data from two populations to make comparisons. You can use random samples to make comparisons. All right, so that's what we're going to be talking about, is comparing the samples. So let's look at what we need to know here. So comparing random samples, 2 bags each contain 1,000 numbered tiles. That's a lot of tiles. The double box and whisker plot represents a random sample of 12 numbers from each bag. Compare the samples using measures of center and variation, which we worked on a lot in the last section. So if you're still feeling uncomfortable about measures of center and measures of variation, I want you to pull out your 8.3 notes, and I want you to keep those with you until you feel comfortable doing these, okay? Can you determine which bag contains tiles with greater numbers? Okay, so let's look at some data here. So what I can tell by looking at bag A and bag B is that both distributions are skewed right. So what does that mean? It's skewed right, so they're off to the right. And so we're going to use the median and the IQR, which IQR again is interquartile range. Okay, so bag A, let's look for the median. We know when we learned about quartiles, we learned that we have it's broke up into 4s, right? We break up our data into 4 sections, and then there are 3 quartiles. We have the lower quartile, we have the median in the middle, and then we have the upper quartile. So I'm going to find my median, which sits right here in the middle, and that's 4 for bag A. The median, so we have our lower quartile, our upper quartile, and then we have our median here in the middle. And our median for bag B is 3. To find my interquartile range, if you remember from the last one, I'm going to take the median from the upper quartile, which is going to be this dot here. So if I'm looking at my upper quartile, it's that dot there that tells me that's my median, and that's 6. And then I'm going to subtract that from the lower quartile's median, which is that dot there, which is 3. So 6 minus 3, my interquartile range is 3. For bag B, my upper quartile is here. Here's my median of my upper quartile, which is 5. And then my lower quartile is here. So my median is 2. So I'm going to do 5 minus 2 equals 3. Okay, so that's how I found my median and how I find my interquartile range. So what does this even mean? So the variation in the samples is about the same, but the sample from bag A has a greater median. So we do know that by just looking at this data, right? The median is 4, the median is 3. It is greater, maybe not a lot, but it is greater. The sample size is too small, however, to conclude that tiles in bag A generally have greater numbers than tiles in bag B, which makes a lot of sense, right? This isn't a very large sample. There's 1,000 numbered tiles, and we only sampled 12 out of those 1,000. This is not a large enough sample to conclude that bag A has higher numbers than bag B. So you're going to do a try it section here at the bottom, and you're going to use this double dot plot. So here's what your try it says. The double dot plot shows the weekly reading habits of a random sample of 10 students in each of the 2 schools. Compare the samples using measures of center and variation. Can you determine which school students read less? Explain. So you're going to look here. Here's school A. Remember, these numbers here that you see down here represent the same lines up here. That's why we call it a double dot plot, because it's the same. This is 0, this is 1, this is 2, this is 3, and so forth and so on. Okay, so you're going to use measures of center, measures of variation. See if you can figure out. Remember, measures of center is our mean and our median. See what you can figure out here. Are you using mean? Are you using median? Then measures of variation would be our interquartile range or our mean of absolute deviation. So you're either going to use the median and the IQR, or you're going to use the mean and the mean of absolute deviation. Okay? So you're going to tell me, can you determine which school students read less? And then you need to explain. Okay? So you're not just going to say school A and then leave it like that. I want to know you know what you're talking about. Okay? So you're going to give me some explanation. This is the last section of this statistics unit. And you are going to be moving into a statistics project. You are going to get to do your own research and start a project. So once you finish this lesson, you're going to come see me, and I'm going to give you some more information, if I haven't already, on the project that you are going to start for statistics. Have a great day.